In our previous lecture on Chapter 16 notes, we talked about the mean of a random variable, or the expected value of a random variable. Anytime we talk about mean, we have to have an idea of spread. Anytime we talk about a measure of center, rather, which is what mean is, we have to talk about spread. And since we're talking about mean in the previous lecture, the idea of spread that gets coupled with mean is that of standard deviation. And we're going to go about it kind of the same way as we used to with plain old regular variables, but we're going to add into the components that come with the probability models as well. So where we're going to start is this idea here. Is we're going to say, all right, well, before we find the standard deviation, we want to find the variance. And we always want to have the variance when we're dealing with these problems. We always want to know what it is or be able to find it pretty quickly, which, as you'll see at the end, is very easy to figure out. We don't have to do all this calculation that we're going to show you. I'm going to show you, but I do think it's important that you understand where it's all coming from. So to start to find the standard deviation, we're going to take the mean, which we found in the previous lecture, is $20. When we're talking about our insurance company that is either issuing $10,000 checks, $5,000 checks, or nothing, they would expect on average $20 a payout, even though no one's going to get $20. If they averaged all their payouts together, it would equal $20. So we're going to take that $20 and subtract it from each outcome, all three of them, and that would be the deviation. Then, since that could produce both positive and negative numbers, and we only want to be dealing with the positive numbers, we want to square those. That gets rid of that negative, the possibility of negative values, which there all are in this case. And so we square that, whatever the deviation is. So the numbers are going to get big, no doubt about it. The numbers are going to get big. But then we're going to multiply them by the corresponding probability. And then once we add all those things up, that's the variance. What it looks like in kind of number form is this right here. Here's most of our table, or the table that we saw before with another column added, and that column is the deviation. We subtracted 20 from each and got those values on the right-hand side. Notice that most people, the greatest probability of payouts is negative $20, right? How that looks mathematically is kind of clunky looking, but rest assured we're not going to have to do it out by, you're not going to be asked to calculate this out by hand or even really show it by hand most times. I mean, it's be ready to if you get asked to, but for more often than not, we're going to be given them, you're being given the information you need and can just work with it. You don't have to get to it, right? But anytime we have standard deviation, calculate the variance, get the variance as well, and you'll see how it's very easy to go backwards from this. But right now, the variance in this situation, which is a measure of spread, is $149,600 square dollars, which doesn't make any sense because what are square dollars, right? We have to square the units too, right? So we want to get, as I said before, this is the second to last step to finding standard deviation. So if you know the variance, to find the standard deviation, we're going to take and square root that variance. We're going to take and find the square root of the variance, and that will give us the standard deviation, right? And likewise, if you have the standard deviation and need to find the variance, you square the standard deviation and you get the variance. It works both ways, right? Because oftentimes you're going to be given the standard deviation, but you need to find the variance, right? So if we look at it here, and again, most of this is the same from the previous slide, right? There's our variance. We want the standard deviation, so it's in actual dollars, not square dollars. We find the square root of that variance, and it's $386.78, which means, well, compared to a really small mean of 20 and a pretty relatively large standard deviation, it means for the most part, the mean says for the most part we're not going to pay out that much, but this large standard deviation speaks to the fact that if they do have to write out a check, it's for thousands of dollars, right, or $10,000. So that accounts for the possibility on the rare occasion that they're going to have to write some big checks. If you're used to the mean always being bigger than the standard deviation, that's going to change. That doesn't have to be that way necessarily, but you'll see why it will kind of, based on numbers, we'll be able to write that ship. Okay. So we start by finding the expected value or the mean, and then from the mean we want the standard deviation, which we get to through this thing called variance. And now let's go through a problem all by ourselves. So what I'd like you to do is I'm going to hit pause, or I'd like you to hit pause and give this a try. I want you to come up with I'd like you to come up with the probability model, the expected value, and the standard deviation for the situation described below. So hit pause now, give this a try, and then I'll go through it in just a second. Hopefully you've had a chance to go through this, and even if you got stuck, don't worry, we're going to go over plenty of these. So our first thing that you want to come up with before you can do anything is our probability model. And we've got three outcomes. You're either going to get a $20 discount, a $10 discount, or no discount. So the outcomes aren't the challenge. It's the probabilities that come with them, I think, are going to pose the challenge. So here's the probability model with their probabilities. Okay? With their probabilities. Most people can see that can get the $20 probability because there are only 4 aces brought out, and only one of them will pay you $20. So if you get a heart on that first flip, you get your $20 discount, and it's as easy as that. But then the rest of it gets a little bit, I think some people get a little confused. So if we're looking at this here, right, and I decided to type these out because my artwork was suffering today. Right, so let's look at the probabilities for each of these. The probability for the heart, as we said, is 1 out of 4. We're only concerned with that if it comes up first. Right, so you have a 1 in 4 chance that you're going to flip over the ace of hearts on the first one. If you get the ace of diamonds, which you have a 1 in 4 chance, right? You get another chance for a lesser discount. And then you have a 1 in 3 probability of getting that ace of hearts because 1's already been flipped over. So now you have a 1 in 3 probability. So the probability that you get a diamond then the heart is 1/12. There's that multiplication rule, right? And I'm going to rewrite this over here because kind of this is going to be 3/12, right? 1/4 is 3/12. And then we don't have to worry about finding a club or a spade because the club or the spade could happen after the diamond too, right? So rather than try to come up with all the possible outcomes of a club first or a spade first or then a diamond first and then a club, or a diamond first and then a spade, I'm just going to say, okay, well, you're either going to get a heart, you're going to get a diamond, then a heart. Everything else is going to be a club or a spade, would result in a club or a spade. So that's going to be 12 eighths or 2/3, right? So that's where those probabilities came from if you were a little confused by what you saw there on that previous screen. Right? So there's our probability model. And again, it shouldn't be a surprise that the restaurant sets it up like this, right? Because they have the greatest chance that they won't have to pay anything, right? But it's not 50-50. Right? It's not. Don't make this mistake of saying, oh, they're half of the cards are black, so you have a 50% chance that you're not going to pay anything. It's even better than that because they have there's multiple opportunities to do it, right? So how much could they expect? This is from the restaurant's point of view. How much would they expect to give as discounts if they did this over a bunch of times? Okay, well, the expected value, what you'd want to do is you want to take 20 times 0.4, 10 times 20 times 0.4, 20 times a quarter, 10 times a 12th, and technically, yes, 0 times 2/3, which we know what it will be, but that will give us the expected value. So our expected value, which would not be hard to show this, right, in this case, would not be hard to show this, would be $5.83. on average, you can expect a discount of $5.83. You're never going to get that for a discount. But if you did this multiple times, if you did this over and over and over again, right, which probably not any one couple is going to do this, but from the restaurant's point of view, on average, they would have to discount $5.83. So maybe they jack up the prices $10 and then they won't worry about, whatever discounts they have to worry about, they have to pay out. The standard deviation, little more involved, or the variance rather, the variance first, right? So we're going to take and really expand what we have here. It's really not that complex to write it out, right? It's almost the same thing, except we say 20 minus 5.83 squared times 1/4 plus 10 minus 5.83 squared times 1/12, and so on and so forth. So our variance is $94.306, which you can leave it like that because it's not gonna really gonna be all that. We're not gonna use it like that, because what we are gonna use is the standard deviation. We're gonna take the standard deviation of that. We're gonna take the square root of 74.306, and we're gonna say that on average, the discount is going to be $5.83 with a standard deviation of $8.62. So that for this discrete variable, which x would represent, right? X would represent the amount of the discount, right? X would represent the amount of the discount. The mean would be $5.83. The standard deviation would be $8.62. Right? So that's how you find the spread of a discrete variable. Let me know if you have any questions. Hope this helped.